All right, so I've got your resume here. Do you want to tell me a little bit about yourself?
Yeah, sure, no problem. I'm Yichong Liu. I'm a rising senior at the University of Massachusetts Amherst. I'm majoring in computer science, minor in mathematics, and I have done some interesting internships and projects before. So I'm interested in applying to your company because your spirit matches my role, and the job is perfectly matches my major.
Sure. So I see here you've got a couple different projects. You got a couple apps, maybe some web development stuff. Is there a particular field, or sort of particular within our company sort of thing that you're interested in doing?
Yeah. In the spring, I and with my teammates we create a website called Lantern. So through which I learned a lot of stuff about web programming, and I know how to design beautiful web pages. I know how to cooperate with backend teammates to you know to establish a well-defined website. And also I also created a word Scrabble game on my own. In the past, I have done. I'm also a good amateur, Android developer. I'm interested in developing the applications as well. So yeah, that's why I decided to apply to your software engineer role. I believe that I can learn more through this job, and in make progress in my career.
All right, great. Okay, so I've got a couple of questions for you. We'll start with one, see how we go through that one, and then maybe a second one after. So I'm just putting that into the chat, and if you could share your screen.
Yeah, sure, no problem. Let me share my screen. Can you see that right now?
Yep.
Okay. So I prefer to implement the solution in Java. Is that okay for you?
Yeah, that's great.
Okay. Given a string s containing just the characters, yeah, these are the parentheses determining of the input string's values. Open brackets must be closed by the same type of brackets. Open brackets must be closed in the correct order. Here. Yeah, okay. So I think this question may have something to do with the stack, because you know you need to match the left bracket to the right brackets, and to determine if it's a valid string. So let's see. So the inputs of the function is a string, and let me see if it only contains the brackets. Yeah, okay. S contains of parentheses only. So I iterate through the string first, and I will find the corresponding brackets. Like there are three types of brackets. And if it's left brackets, I will I will probably to put it into the stack.
Sure.
And if it's right brackets, I will so the top n elements from the stack, and check if it's matched. Does my idea sounds okay to you?
Yeah, that seems good to me. Why don't you write some
Yeah.
code?
Okay. So let me see. So first of all, I will iterate through the string, of course, for this is a simple for loop. So now I can define a stack. The stack should be consist of characters. And so if SI is equal to what the first type of brackets, or this is the second type of brackets. Oh, sorry. This is the third type of brackets. It has this autocomplete function, so I have to remove this. And let's see. I forget whether it's add or put. Let me see the stack. Does Java
I'm not sure about Java. I would imagine it might be push. Stacks are often push.
Yeah, push maybe.
Could be. Yeah, that'd be my guess. Oh, maybe not.
Yeah. I think it's whether push or push. We can check that later.
Yeah.
So
sure.
that's the push SI.
Yep.
So change these to the right brackets.
Sure.
So initialize a new variable. And so if the right does not match the SI here, I will return false in this condition.
Sure.
So if all of them matches the the stack, all of elements in the stack are pops, and and it seems, and maybe the string is valid under this. So okay, I will just simply return. Not sure if I use the correct one. That's for the size. I don't know.
Yeah, I'm not sure about in Java.
Symbol. Okay, cannot find symbol. Okay, so
should it be a capital S for stack for the type?
Oh, okay. So it's not it's not an array, so it should be the Esther child. Yeah. Just need to,
for the string. Yes, that's yeah. let's see. Oh yeah, one more. Stack. Okay. Okay. Let's test more. Oh, so which one? Let's see the difference.
Let's see. Yeah, so here the output result is true, but expected to be false. So the stack is empty in this case, but you know, I think it should return false somehow, my idea. So let me go through my solution real quick.
Sure.
Let's do the pop. It's weird. It doesn't output anything.
So I believe
Oh, yeah,
your
yeah.
issue is you have ands instead of ors in your if and else if statements.
Oh, okay. Yeah.
Yeah.
That's one part.
Yeah.
Yeah, that's a good part. Okay, let me see if it's one correctly. Yeah. Okay. Still some error here. Oh, okay. So, here is returning false. And we run this again.
So
Oh, okay. Oh,
yeah.
so sorry. Yeah, it doesn't equal to. So I should create a condition that really matches the left bracket and right brackets.
Yeah.
So let me think. My initial idea, intuition idea is yeah, make sure. So it's like I should name it as left. That makes more sense. So if it's duplicate left. So it's like left your index. So left brackets equals to the right index of as the char at I. Yeah, here it should be not equal. Okay, let me check this again. Okay, let me see if we run smoothly. Let's see. Runtime error. Empty stack exception. Oh yeah, so I need to add a condition here.
Yeah, maybe it'd be better to check if the size is 0 and then return false. So that way you can,
Yeah.
yeah. And then you can take that outside. Yeah.
Let's see the part. Yeah, let me see. All right. Yeah. It's not
Okay.
very efficient, but we passed the test.
Yeah. Do you have any ideas of what could make it more efficient or? Oh,
Yeah,
so
let me analyze the time complexity here. So I
sure.
use one for loop. I create a stack. You know, I noticed that besides this for loop, I still use the lefter index or righter index. So that it requires to go through the string each time. So it's sometimes it's not very efficient. Do you want me to simplify the solution?
No, I think that's fine. So I think one thing is if you get rid of your print statement, that usually is, at least in leet code, a big a time sink. But yeah, no, I think this is, I mean, it's O of n time. It looks fine. Probably what would be a little better is to have some type of hash map to determine the brackets, matching the brackets rather than doing that string index of. But I mean, for only 3 brackets, I don't think that's not going to be a big deal. But yeah, so yeah, I think that was all right. Good job.
Yeah.
Okay. Do you want to take a crack at one more?
Yeah, sure, no problem.
All right. I'll give you one more in the chat.
Okay. Can you see my screen?
Yep.
Okay, let me read through this question.
Sure.
There is a robot on an m times n grid. The robot is initially located at the top left corner. Yeah, given the index and number of possible paths. What is solved? I guess it's a dynamic programming problem, or the DFS or BFS. No. So let me go to example. If m is 3 and 7, and output should be 28. M is 3 and is 2, 3. Okay, so it's like right, down, 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 right, down, right, down. Okay. The test cases are generated, so less than okay. I think so. The inputs are there are only 2 integers.
Yep.
Okay.
Yeah, and for this one, I mean, you don't necessarily need to get all the way through it, but I think if you could provide me with like a good idea of how you would go about doing it, that'd be good.
Let me see. One second. So if I use the DFS, then I will go through the. Do you think I can apply the greedy algorithm under this case?
I think, yeah, well, okay, I would probably go about it using DFS.
Oh, sorry, I can't hear you.
Oh, hello. Hello? Was it
Sorry
an
about
issue
that.
with?
I need to change the setting.
Yes, it is. Yeah.
So yeah, okay. So I think, yeah. So each time, the robot can do two options, either go right or go down.
Hmm.
So, I think this has something to do with the dynamic programming. I can think of an algorithm. So if I use this to, so first, the initial, index should be 0, 0, and I need to go to the m minus 1 to n minus 1, if I understand correctly.
Yep.
And yeah, okay. So it's like, DFS should be, first I can try to go right, as deep as possible. And after I reach a point, I can choose to go down. And then after, go down as deep as possible, check if I still need to go right or go down. Not sure if my idea was correct.
Yeah, so I think definitely DFS is right. I mean, I think one thing you can note is that you are, well, I'm not sure it's really necessary, but you are on a rectangular grid. So you do know that, if you're going all the way over right and then down, then you'll get there. But yeah, I think the intuition with DFS is right, and dynamic programming, absolutely. So with the dynamic programming, could you just walk me through a little bit of your thought process of how the dynamic programming will help, and like where you would implement that, just before you get started real quick?
Yeah, no problem. So do you think I need to use, implement a recursive solution in this case?
I think recursion works pretty well here. It's
Yeah, I can think of something in my mind, so I can try to implement that.
yeah, go for it. Yeah.
Yeah. Okay. So the unique path definitely returns. So right path. So if I choose to go one step right, I will, then it becomes unique path, so it's like m minus 1 n, and then the down path is m n minus 1. So I need to find a way to combine them and do a sum of them. And
Sure. Yeah.
right path, it's like, so first let's consider some edge case. Yeah. The recursive solution does the, definitely needs edge case. So if m either m or n is equal to 0, and that means I have only one way to go. Maybe, that is go through the boundary. So I will return 1. And then I should return maybe the summation of the unique path and 1 or unique n minus 1. Not sure if I understand this correctly. Let's test it. Okay, that's definitely not correct. So I must be missing something here. 1, 2. Oh yeah, I need to make us, to check if it's really going right or going down. Unique path.
I think your intuition is right. I think you have an off by 1 issue. I think you should be checking if m and n are 1, I think, because you're going to m minus 1 and n minus 1. So
yeah, I think
that, I think that might be right, but okay. Okay, so as this is running, and I assume this is time limit exceeded.
Yeah.
So
is it really time consuming?
What is your sort of your next idea as to you mentioned dynamic programming earlier. How could that help? What's your idea there?
Yeah, this recursive solution is definitely time consuming. So
I think recursion is fine. I think you need some way of I guess the problem with this recursive solution is if you've seen this this function call before, if you've already been to this square, you're recalculating it all the way down. And so that's where dynamic programming could come in and increase the efficiency if you have some type of cache for knowing how many paths there are from any one square.
Okay.
Yeah. So
let's see. I think maybe the second example, give some hints to implement the dynamic programming. Right, down, 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 right, down, right, down. So if m is 2 down, right, down. Let's see.
Yeah, I think the example was 9 and 51 was the one you failed on the
Yeah, okay. I'm testing some large values. Give me some into.
I think it was 9 and 51.
Okay.
Yeah.
Oh,
I think 50 and 51 is a little big. So
yeah, I think I can see it's really time consuming here. So splits that to the S cases. I'm not sure if I, this maybe not very right, but sometimes in competitive programming, you need to add more edge cases to make it faster. I can definitely try that. So it's like M is 2, N is 1. Okay. Oh, it's so.
Well, I think you're sort of getting at the idea that we want to get to here, which is at any sort of pair of M and N, you can sort of if you've seen it before and if you've calculated it before, you can just return it right away, right? You don't have to go and do the recursive steps.
Yeah, I think. Oh,
well,
yeah,
there you go.
works much better. Let's see if I pass the test. I think I doubt it. Yeah, it's still not working, but it's
Yeah.
definitely increased the. Let's watch if what happens to when M is 3. So it's like M is 3 and is 7. It's really hard to say what the answer would look like. So, any idea how to simplify a solution based on this?
So there is an explicit solution using combinatorics. If you remember your statistics, there is an equation that gives you, if you take an M and an N, it will spit out the right number for you. I don't know what it is off the top of my head, so I can't really help you with that. But I know there is an explicit solution to this question. So,
Okay.
yeah.
Yeah, let me think. Three ways to reach the bottom right corner. Oh yeah, statistically, there may be some. Let me think.
Yeah, it's like M choose N something.
And I think there's some formula to calculate.
There is a formula, yeah, because this is essentially at every position you can move right or you can move down. And so you have to move right M times and you have to move left down N times. So there's an explicit solution
yeah.
where
that's what you mean. Yeah.
You sort of, how many ways can you order M and N, right? And so there is an explicit solution for that. Like I said, I don't remember it off the top of my head.
You are absolutely right.
Yeah.
Let me use a join wheel. Yeah. Okay. So it's like I'm just trying to. Yes. Okay, then I guess it's not this one. Let me see. 3, 2, 3. 4, 7. Either go right or go. So I'm trying to think of all the formulas I remember.
Yeah. So, and I'm sure you could figure this out. So I think your intuition with DFS was spot on. You had the intuition to see that this is a dynamic programming problem. Like if you're not going for the explicit solution, then you definitely want to use dynamic programming for this. So I think that intuition was there. So yeah, and this is a functioning solution. It's a little bit slow. But yeah, so great. Is there anything that you'd want to ask me about the company?
No, I think it's a perfect interview for me.
All right, great. All right, well, thanks.
Yeah, nice.